Good morning students, welcome to today's session. I hope every one of you understood what and all we have seen so far in the last video under the chapter lines and angles. And so already you know that some type of specific angles, everything. There's some properties of angles also. And here we are seeing about the lines and the angles made by the lines. Okay, the last class we have seen so many different type of angles also. Okay, so before going to today's session, let us recall what we have seen so far in the last classes. Okay, so our topic is nothing but lines and angles, and the types of some basic angles is nothing but these 6 angles: acute angle, right angle, obtuse angle, straight angle, reflex angle, and full angle, that is full rotation, that is 60 degree, 360 degree. So here the acute angle is nothing but it is less than 90 degree only, and the angle exactly 90 degree means it is right angle, and exactly 180 degree, that is the straight line, that is minimum less than 180 degree means it is called obtuse angle, and exactly 180 degree means straight angle, and more than 180 degree means it is a reflex angle, and the angle which complete a full revolution means it is called full rotation, that is 360 degree angle. This is already you know that. Okay, and some other specific angles nothing but complementary angles. So complementary angles nothing but sum of the angles, two angles equal to 90 degree. For example, 50 plus 40, so 50 and 40 are complementary angles, 30 and 60 are complementary angles, so like that. So if the sum of two angles equal to 90 degree, then they are said to be complementary angles. And supplementary angles, so one example of the supplementary angle is nothing but 120, 60, that is sum of the two angles equal to 180 degree, then the angles it will be supplementary angles. Okay, this is one of the example. And linear pair of angles, that is if a straight line can be divided into some two angles, and sum of those angles equal to 180 degree means that is called linear pair of angles. For example, this one 30 degree means, so this one 150 degree. So here this A O B is a straight line. Okay, and this straight line divided by the ray O R. Okay, so this angle ROB 30 degree and AOR 150 degree. So sum of these two angles is nothing but linear pair of angles. That is, the straight line angles can be divided into two here. So that's why. And adjacent angles. If the two angles having a common vertex or lies on the common vertex, then these angles, that is those angles are said to be adjacent angles. Okay, so here this angle, that is this ABD, so this angle, and DBC, this angle having the common vertex B. Okay, that's why these two angles are said to be adjacent angles. So in the diagram, angle ABD and angle DBC are adjacent angles. Okay, and next to vertically opposite angles. If two lines are intersecting like this, so some of the angles so formed, that is 4 angles so formed. So 1, 2, 3, 4. So 1 and 3 are opposite, vertically opposite angles, and 4 and 2 are vertically opposite angles. Okay, and these are the definitions. So these are the definitions of acute angle, right angle, obtuse angle, everything. Okay, so already we have seen this kind of angles in the last classes, and next we are going to see some examples, okay, based on these kind of angles. So look at this example. So here in the figure 6.10, that is, this is the figure. Okay, this is a given diagram. So OS stands on a line POQ, this one. Okay, OS stands on a line POQ. Here POQ is a straight line, and OR and OT are the angle bisectors. Angle bisectors of POS and SOQ. Okay, so angle bisector means what? Suppose it is one of the angle, okay, that is 40 degree means, so angle bisector, for example this one is angle bisector means, So here 20 degree and 20 degree. So a ray which divides an angle into two equal parts, that is into two equal angles, means that is called the angle bisector. Okay. So in the similar way, so here OR and OT are angle bisectors given here. So OR is nothing but this one. This OR divides which angle? That's POS. Okay, that is this angle and this angle. These two angles are same. It's already marked here. Okay, this marking represents both are same. Similarly, OT is another ray. It divides this SOQ into two equal angles. So here marked with a single mark. Okay, so if marked like this, they are equal angles. Okay, that is given thing. And also one more thing also given here. So angle POS equal to X. So find ROT. So they are asking to find out ROT. That means they are asking to find out this angle only. Okay. So what and all given here? So given here POQ is a straight line. Okay. And OR, OS, OT are three rays at the point O. Right. And here OR divides this POS into two equal angles. Okay, and similarly this OT divides this SOQ into two equal angles. That's it. And also POS equal to X, they are given here. We are going to find out angle ROT. Okay, now listen here. So angle POS equal to X. So this is given. It is given here. Okay, so from the diagram, so this angle is nothing but X, that is POS. Okay, that is given here. And what about this angle? So this one fully 180 degree. Okay, so listen here, the diagram is like this, POQ. Okay, so this one, yes, this one, let us take this one as O. Right, so what is given means this POS is nothing but X given here. And what about this one? Okay, so this one is nothing but 180 minus 6. How it is 180 minus 6 means it is a linear pair of angles. POQ is a straight line, so 180 degree. So one of the angle X degree and another one 180 minus 6. And for another example, suppose, so this is a straight line. So this one 40 degree means what about this one? So this one 140, because we have to subtract from 180. So likewise here this one X means this one 180 minus 6. Okay, so here right, so POS equal to X, therefore angle SOQ equal to 180 minus 6, right? And one more thing, so here POS equal to X given, and this angle now only we found that is 180 minus X, and OT is the bisector, right? So OT is the bisector. So OT bisector means what about SOT and so SOT equal to angle TOQ definitely, because these two angles are same, because there is a angle bisector given. So SOQ is nothing but 180 minus 6. So what about these two angles? So these are the half of this angle definitely. Therefore, these two angles equal to 180 minus X divided by 2, half of the angle. So equal to, now simplify this. So 180 divided by 2 minus X by 2. So equal to, so 90 minus X by 2. Okay, so what is 90 minus X by 2 means? This angle is 90 minus X by 2, 90 minus X by 2, and this angle is nothing but 90 minus X by 2. Okay, And what about this one? So this one POS fully X, and this is the angle bisector, that is angle POS equal to X already given, and in that RO is angle bisector. So OR is the angle bisector, means these two angles are same, right? That is angle POR equal to angle ROS. So both are same, equal to. So full angle is X. And what about this one? So X divided by 2, half of the angle. So angle POR equal to X by 2 and ROS equal to X by 2. So this one X by 2 and this one X by 2. And what they are asking here, they are asking angle ROT. So angle ROT equal to, from the diagram, so ROT means sum of this angle and this angle, okay, that is angle ROS plus angle SOT. So ROS is nothing but X by 2 and plus SOT is 90 minus X by 2. So this plus X by 2 and this minus X by 2 get cancelled. So remaining 90 degree. So angle ROT is nothing but 90 degree. So that is the procedure. Okay. Right. Look at the next example. So the figure 6.11. So here, that is OP, OQ and OR and OS. Here all the 4 rays given here. All are 4 rays. Prove that POQ, that is POQ this angle, and OQR this angle, and O, that is SOR and POS. So everything, sum of these angles equal to 360 degree. They are asking to prove like this. Okay. So for this, I'm going to draw one construction here. That is, so draw. That is our extend QO like this. So extend QO up to OT, right? So here this one QT is a straight line now. Now what about this one? It is 180 degree now. Okay. Now, so from the figure, how can we write now after construction? So it is TOP. So angle TOP plus angle POQ equal to 180 degree, because straight line. So this angle and this angle equal to 180 degree. Let us take this as equation number 1. And what about down here? So 1, 2, 3. Sum of the 3 angles, that is angle TOS plus angle SOR plus angle ROQ equal to definitely 180 degree, because down also straight line only, it can be divided into 3 parts. So that's why, that is equation number 2. Now add 1 and 2. If you add 1 plus 2 means what will happen? So angle TOP plus angle POQ plus angle TOS plus angle SOR plus angle ROQ equal to 180 plus 180 equal to 360 degree. I am adding left hand side and right hand side separately. Okay, add it like that. So next here, what we are going to prove means POQ, QOR, SOR and POS. So POQ is there or not? So POQ is here, and QOR, so QR is not there. SOR, so SOR is here, and POS, so POS is not, okay, POS is not here. And instead of that, so what of the remaining one? So remaining one is nothing but TOP, that is TOP. So angle TOP plus TOS plus angle ROQ, and the remaining 2 angles POQ plus angle SOR. Actually I rearranged this, okay, I rearranged this value here. So what about the angle of TOP? That is TOP is nothing but this one, and TOS is this one, and ROQ is this one. Okay, so right, let us continue in the next slide.